What's on the test tomorrow? What about L'Hopital's? What are the different ways of L'Hopital's being allowed to be used? Infinity over infinity, and are we evaluating integrals or bless you, only evaluating limits? Don't try to use L'Hopital's when you're evaluating an integral. What are the kinds of tricks we used when we had to do L'Hopital's? So force it to be a fraction. So there are other things you can do to force it to be a fraction, but that's a big one. What was another big technique we used? Eton? E to the ln to move the exponent down. Any other tricks you guys want to list up there for L'Hopital's warnings? Yeah.
Like sometimes you have to use it when you're doing limit comparison.
Oh. Didn't think of that. Okay. So L'Hopital's is used for those indeterminate forms. 1 to the infinity, 0 to the 0, infinity to the 0, infinity minus infinity. All right, what was another thing we did? Okay. The convergence tests. Limit comparison. And if you get a not 0, not infinity number, what does it mean? Doesn't mean convergence. It means they both approach infinity at the same rate. Okay. And I'm typing them because you might not have been able to see what I was writing for the last week because it's a mess. All right. So that doesn't prove convergence. What was another P series? It'll converge if what? P is equal to 1, less than 1, greater than 1, less than or equal to, greater than or equal to. It's one of them. Strictly greater. What else do we do? So if the top function converges, what do we know about the bottom function? What's the one about the bottom function? If it And then if it's the other way around, the top function diverges, you don't know anything about the bottom. It might diverge also, or it might go be calm. And if the bottom function converges, you don't know if the top function, whatever. There was at least one more thing we did.
Just like straight up integration.
What were the three conditions to make it work? Positive. Okay. Oh. Did we do anything else? Evaluating limits to infinity. And in delta math, they did a lot of they asked you to translate that to an integral, because technically this is the series and it's modeled by an integral. So writing that as an integral, what does it become?
Integral of 1 over n between 1 and infinity.
They would have changed the letter. Oh yeah. So the little sigma thing becomes a squiggle.
Here, when you're doing something like that, you not have to put the limit as b versus infinity.
If it's just asking to do the translation, like what is this summation as a integral? No. But if you're, so that's another thing on here. And there was something else that didn't get listed here, and that was integrating over a discontinuity. We're not going to infinity, but could we integrate that? Like, there's a discontinuity at 2 at the very end. Can we do that? So notation pulling that stuff out. Okay. Questions on stuff. The answer key to the worksheet from yesterday is up. And there are choices on these. So the answer key doesn't have all options, but it has an option. And sorry for the kind of faded stuff. Number 8, the last one, you can integrate by doing arctan and you'll get a number. Those of you who looked at the sample test, it says for 2 of the questions, number 5 and the first number 6 versus the second number 6 and number 7. Does evaluator state that it diverges or show that it diverges? So that's 2 different things, and they're asking you to actually integrate. So when it says evaluate the integral, they're asking you to actually integrate. And one of them was a U substitution and the other was arc sine. And one of them converged and one of them diverged. Then there are 2 tests on here that say just does it converge or diverge? Don't actually integrate, but it's telling you basically do one of the tests. This is one that is pain. Direct comparison. If there's that trig function in it, you can't get around it. One of the later classes yesterday was arguing, but it's stuck between 2 and 4. Can't I just? No, you can't just. Because when you do limit comparison, it didn't come out to a number, it came out to a range of numbers. Definitely a finite set of range of numbers divided by infinity, it's going to end up being 0 and it'll be okay, but no. So these two with the trig function on top or the denominator, you need to use direct comparison. Questions on stuff? Yeah.
In number 8 and I think so number 2, like the ones that give out to numbers, do you have to say like by integration tests? Or just leave it as they
Okay, for me, no. For the AP exam, probably.
Okay.
I haven't done enough of these grading wise, but the AP exam, question 6 is always on this kind of stuff in chapter 9. And if you're using a convergence test, you usually need to say the reasons why you can use it. If you're using mean value theorem, you need to say the function is continuous over the closed interval and it's differentiable over the open interval, so there is a place that the average will equal the answer. Like you need to say that if it's on the free response. If it's in multiple choice, you can just be like, 3, it's B, yay. So if you're using integration tests, you might have to say, because it's positive, decreasing, and continuous, and I integrated and got a number, it can.
I did number 8 like the first way, but if I did it the second way, when you pull out, like I get the first step in the setup, like pulling out the 9 from the denominator, how did that become a 3? From U substitution?
Yeah.
Okay.
Like chain rule, divide by the derivative of the second side, so dividing by 1/3 is multiplying by 3.
So for P series, doesn't matter if it's like going from a negative infinity or going to infinity.
It does not matter. Well, if it's squared and underneath. No, I don't believe it should matter. The one thing that matters is, as long as I don't make a crossover at discontinuity, which I never intend to, but I have. Let the test go too fast. So,
For what we were going over before with like the direct comparison and top functions with bottom functions, isn't it the one that's like bigger or smaller rather than top or bottom, or does it always correlate?
well, saying if the trig function's in the denominator, the issue is P series no longer works, was the point of that. And I'll have to do some other comparison. And so, sorry, say your question again.
Like if you're looking at like a function over a function and you're trying to figure out if like they both like converge or diverge by direct comparison, would you use like you said, if the top one converges, they both converge, but isn't it like if the bigger one converges, they both converge?
So it depends on which way you're going.
Okay.
So this one, I need to know the answer before I start. So looking at this, if I said this is like 4 over x, would that converge or diverge? Diverge by P series. So the papers thing, I want them to diverge. If the top one diverges, I pick the top one to make it diverge. Do I know anything about the bottom one? So no, I need to pick an equation that will be forever and always under that guy. Okay. What's an equation that will be under that? Will 4 over x be forever and always under that equation?
No, because it's like
Okay, how do we know? What's the biggest number that comes out of sine? 1. So 3 plus 1,
so less.
So the biggest that comes out of that numerator is a 4. This equation would be always on top. Don't want that because I know it's going to diverge. So I'm going to pick 2 or 1.
Because you know that it's like smaller.
It's a little bit under.
Yeah, okay.
Okay, going to change it because you said something about always this. Now it's squared. What's your instinct? Is it going to converge or diverge?
Converge.
Now it's going to converge. So now I need the equation on the top to squish the one underneath. So now I need an equation on the top. So I used this one when it was under. I'm going to use that one for over.
Okay, thank you.
So it's not a always this. You got to look at the situation and see what you need to do.
When you're given a problem, how do you know to use like the different tests?
You don't, because a lot of them you can do different stuff. This one, I was able to integrate, so I did. But I could have done, like, this would be one that I would say evaluate or show that it diverges. But if I just said, does it converge or diverge, I could have done comparison test, limit comparison, and then said by p-series, 1 over x to the 5th converges, by limit comparison, these went to infinity at the same rate, therefore they both converge. This one, I did the direct comparison, which is a little gutsy. And then said this one converges by p-series, so they both do. I could have done the comparison myself. So I think I didn't talk about using direct comparison with these guys yesterday. The other classes wanted to do it, and all right, fine, you can, and be careful. The coefficient, or the exponent down here kind of boils down to 3/2, so I know it's going to converge. Because it's going to converge, I need a function always on top. Can anyone reason why this one is above?
You're adding 1 to the denominator, so the denominator is getting bigger in the square root, so you're dividing it by 1.
Okay, so the way I explained it, yes. I explained it to the other classes as like, okay, I have a 1 pizza. I'm going to share the pizza with the whole class. Sasha invites a friend. Do we get more pizza or less pizza? Because she invited a friend. We get less pizza. But what if we were mad at Sasha and said she has to not come to the party anymore because she invited a friend? What if this was a minus? We kicked her off the island. Now we're sharing with one less person and the argument no longer works the way you want it. Now this one is above, so it's really dangerous to use direct comparison.
Can you always just do -2 then?
Then it doesn't fit p-series. That's the problem.
If it's dangerous, then what else would you do?
Oh, I would do this, I would do limit comparison. So the answer key is up there to show different techniques. There were other options. Direct comparison, like here, you don't have a choice because limit comparison wiggles.
Which one is limit comparison?
Limit comparison is when you say, where'd it go? This function behaves like 1 over x. You do the New York sheet, strip down the exponents from the top and bottom, fully reduced, it behaves like 1 over x. I'll prove it. Do one function divided by the other, and then pre-cal happened. That one's going to go off to 1. Okay, by limit comparison, these two functions approach infinity at the same rate. Doesn't tell me anything about them converging or diverging, but I picked this one with no coefficients hanging off because I know it diverges by p series. So if this one diverges by p series and they're holding hands at infinity, that guy is chain 2 and he's going to diverge also.
When you say P series, you have to explain that it will like converge or diverge and use the
For whatever reason, they do not make you explain anything about p series. They're like, yeah, cool. I'm like, okay. Everything else you make them say, can't just say integration, you gotta say integration test. Can't just say nth term, you gotta say nth term test. So they're like, yeah, p series, it's all good.
So if you're not integrating like number one and number two, you could use Q substitution, then you would use P series for all of the comparison tests.
Generally. So if you're using a comparison test, you need something else to say why it works. One of these had e to the x on it, and I had to actually then integrate e because it is not p series.
Like what kind of integration techniques might be on it other than U sub? Or is that mostly
Well,
like integration by parts?
no.
Okay.
Oh my god. That with this. There were some hidden trig inverses in some of the examples. So U sub, trig inverses, it doesn't usually get fancier than that.
Could you not just like for number 2, could you like use limit comparison for that one?
Yeah.
Okay.
And again, it depends on the instructions. If I told you evaluate this integral if possible or show that it diverges, then you gotta try and integrate.
Okay.
Tom, did you have another question? Have you guys looked at the,
I have a question about the integration test. Like how do you know if you should do the integration test before?
well,
Like if it goes to a number or if it just goes
okay. First of all, if the number goes, if it's 2 to 5 or something, integrate it.
Yeah.
Like if it's a strict interval that I'm telling you for this particular test, there's a discontinuity somewhere, probably on the edges. And I just want to see, can you do the process of pulling that limit out and then doing the integration? Otherwise, when we do integrate, when I see the U substitution staring at me, I tend to integrate. Clearly I didn't over here, but again, I wanted to show variation in solution methods. But the first one I could have used sub and integrated. Same with number 2. So there were choices.
For the direct comparison test, how do you know if you want to compare it to a bigger function or a small function?
Okay, so Fiona and I went over that. Fiona, how do you know in direct comparison if we want a bigger function or a smaller function?
It depends like when you like compare it. If it, I don't know how to explain it. Like it depends. Like the other one that we were doing, where you have like the 3 plus sine x over x. When you compare it, since you have like you want a function that's smaller because
I know the answer in advance.
yeah, exactly, because it diverges.
So, Sydney, do you know why we know the answer in advance? Okay, what's the thing in the denominator? Just x, and some number up here. So some number, not infinity, over x. By p series, would that thing converge or diverge? Diverge. And because that's gonna diverge, I need to find one over or under to make the other one also diverge. Okay, if the top one diverges, do I know anything about the bottom? Okay, so I need to find an equation under it to force that one on the top to diverge. So this is the one that's on the top, I need to find something under it. What's gonna be under it?
2 over x.
2 over x, or 1 over x, or 0.3 over x if you want to be cute about it. Okay, and as we did earlier, I'm going to change the problem. It's now x squared. Is that going to converge-ish or diverge? Converge. So now if I have the equation underneath converging, do I know anything about the one on top? No, so now I need to find one on top that it will squish the white one down. So what's something that's over 4 over x squared? Right, Sean? Yeah. Okay. All that stuff. Let's see. Which one of these looks horrible? Try that one. This is pretty heavy. So, oh, so you need a little more success. Okay, we don't do it with the number one, we do the comparison. So it's just keep the limit of x divided by the other guy. And to do it more complicated. Okay. Seeing some process issues. What's the first step? Alex, what's the first step?
Well, I saw that it's similar to 1 over x.
So, great, yes, it's similar to that.
Then, as a p series, you get back that the exponent
Okay, I need to do math to prove any of the things you're saying. You're just like, so we're done because it's gonna converge. Again, you need to know the answers before you start. So yes, we know it's gonna converge. Now what do I have to do? What's limit comparison? Does the limit, when we're doing limit comparison, do we keep the little squiggle? Do we keep the integral line? No, so it's just the function that I'm given divided by the function that Alex picked. Jasper, why did he pick that function? Where did that number come from? Highest exponent on the top, highest exponent on the bottom, reduce them. X to the half over x squared is x to the 3/2. Okay. So that's x squared over x squared. You don't need to do L'Hopital's in this case. This is a pre-cal thing. You could do it last year. Forget the whole thing from L'Hopital's. Where does this go? 1. Because it's not top heavy, it's not bottom heavy. It's just same power. It's the coefficient in front of both of those, 1. So Josh, right here, what do I need to say in words on the test tomorrow about what happens with this? Okay. Both functions approach infinity at the same rate. They don't just go together. Where are they going? They're going to infinity. So some of you are a little light in the words and you will lose credit tomorrow if you are not explicit. But I haven't proved convergence. Martin, what do I need to do to prove that it converges or diverges?
So, say 5p series 1 over x to the 3 converges, and then like the 3 dots, therefore.
So we chose that one because it converges by p series. And then you said do what?
Yeah, the 3 dots, therefore square root of x over x squared plus 1 also converges by limit comparison.
I'll put the by limit comparison up there. Sean?
Can you do the direct comparison for this one too?
Does direct comparison work? That I want it to converge, I want somebody above, and that one because they invited one more person to the party, they got less num-nums, yeah. Dicey, it was a -1. And you declare it so, that's the issue with direct comparison. I declare it to be true, and if it's not true, the whole problem is wrong. But I usually say both functions converge, but he said the whole name of the function and said, therefore that one converges. Perfectly fine. Tie them together. Now, why did you tie that first function to this other one that you picked? There had to have been a reason because you knew something about that function. And say, then they both got to do this thing. Okay? Ew. What else? Y'all got 10 minutes. You can do the sample quiz. There's also a optional chapter 8 set of stuff out there, a bunch of stuff on L'Hopital's, and then a bunch of stuff on the convergence tests.
How would you include that x over e to the x?
How would we do that one? And as I said, we normally need to know the answer in advance. Do you think it's going to converge or diverge? Probably converge, because if x squared converges, e to the x is like large. So maybe compared to that. And unfortunately, I can't say, oh, well, pre-cal happened. But that is what happens.
So could you use substitution and choose like x as like mu, or how does that make sense?
If I chose use substitution, it doesn't work. So what does this mean that this came out to infinity? Luke, what?
X over e to the x goes a lot faster.
So that's not going to help me. So let's see, what if we rewrite it in a way we've seen it before? Let's see, what does that remind you of? We said it earlier today, and I was like, no, we won't do those.
Oh, like integration of parts.
Yeah,
Tabular.
tabular. Gross. So, okay, we can integrate that by tabular. So try it. We did this one in class, it was long and painful. It was the reminder of all the things. Integration by parts, L'Hopital's, and everything, especially this stuff. Can I be lazy and skip a step? Instead of having e to the negative x up there, can I just call it e to the x down there? So I have a fraction. Am I allowed to do L'Hopital's with this or test to see if it works because I have a fraction? Thank you. So if b goes to infinity, negative b plus 1, then minus negative 1 plus 1. Negative infinity minus 2 is negative infinity. Does L'Hopital's apply? Yeah, okay, Camden, how do I do the derivative of the top?
It's just one.
Negative 1, okay. Over, Massimo, what's the derivative of the bottom? Just d dx. So what happens? Plugging in b, plugging in infinity is 0 minus negative 1 over e to the 1. It's 1 over e. So does it converge or diverge? Converges. Was it a pain in the butt? Yeah. Is it on tomorrow's test that specifically? No.
Instead of using tabular, can you just do x over e to x and like make it eliminate to L'Hopital? That instead.
That is testing that thing, not its integral. Like you had to integrate it and see does it converge. So, no, even though it looks just like what you said, but yeah. Scalia?
Is there any way you could have done like direct comparison just because like you know that x over e dx is always going to be bigger than 1 over e dx?
If I want a direct comparison, I need something above that.
Oh, yeah. Sorry.
Hannah?
What did you do with like the input?
This
Yeah.
stuff? So, I was doing L'Hopital's with, here's the numerator. And I plugged in, both pieces. The numerator at infinity goes to negative infinity, and the denominator at infinity also goes to infinity, so just showing that L'Hopital's applies. Okay.